Two particles of equal charge in limiting equilibrium. Here, the interesting aspect is that the limiting equilibrium is maintained by the force of friction. So, the force of friction maintains the equilibrium, which means the force of repulsion between the like charges is equal to the force of friction. We can use this value to find the, yeah, that's right, coefficient of friction over here, which is the coefficient of static friction. So we all know what the coefficient of static friction is. The coefficient of static friction is very simple. Force of static friction is equal to coefficient of static friction multiplied by the normal force. Remember, you hear that right? That's right, the normal force is the value of the coefficient of static friction. So similarly, what is Coulomb's law, which is the net force, right? Net force due to both the particles here. So the net force on both the particles is k q1 q2 by r squared. So we'll just multiply 10 minus 7 the whole squared, all divided by 10 by 100 the whole squared, which is 0.1 the whole squared, or should I say 10 minus 1 the whole squared. There you go. So we have something related to 9 to 10 to the power 9, right, on the right side. So similarly, we just had to find mu s here. Mu s is equal to fs over n. Yeah, because we are going to be equating everything here. We're going to be equating the force of static friction and the force of repulsion as well. So that's how we are going to be ending up with our desired answer. So let's find the force net in the meantime. 9 into 10 to the power 9 multiplied by 10 to the power minus 14 into 10 to the power, now remember, from the denominator I'm bringing it to the top, so I'll be ending up with 9 to 10 to the power minus 3 Newton. So that's going to be the value of force net. This is going to be the same as the value of static friction as well, remember, because the entire system is in equilibrium. So finally I'm going to solve for static friction as well by equating it. So I will equate my values, 9 to 10 to the power minus 3. And now, what is the normal force here? There are two particles here, right? Two particles having mass 5. 5 plus 5, 10. 10 grams. So 10 grams I have to convert into kilograms. So 10 into 10 to the power minus 3, which is 10 to the power minus 2 kilograms. This is my final answer. So I'm just going to oh, I forgot gravity for a moment over there. Yeah, I forgot gravity. How silly of me. So 10 to the power minus 1, 9 into 10 to the power minus 2 is your final answer for the coefficient of static friction of the system. Thank you so much, dear students.